My name is Kevin Mackley. I'm Vice President of Global Marketing for 3D Systems, based at our new facility in Rock Hill, South Carolina. 3D is a company based in the United States, but we have offices and facilities around the world. Like all of these additive processes, stereolithography starts by taking three-dimensional CAD information, slicing that data into thin layers, and then feeding that data to the machine, and the machine, of course, reconstructs the part layer by layer in an additive fashion. In stereolithography, the actual process utilizes a vat of UV curable liquid and a UV laser with scanning mirrors. And as the sliced data is fed to the scanners, the laser scans across the surface and supplies laser energy only where you have part cross-section. And in those areas, it selectively solidifies the material, and once it's completed one scan region, a build platform is lowered into the vat by an amount equal to the layer thickness, and you then smooth that layer if necessary, and then you rescan the next layer, and you supply enough energy such that the new layer is solidified and adhered to the previous layers, and you keep repeating those steps until you reconstruct the three-dimensional object. Because you work in a liquid, you build what are called support structures, and those support structures anchor those unsupported portions of the part down to the build platform until you've got them in place and then added more material on top of them. Stereolithography excels at building very high-resolution parts. Because you work in a liquid and because a UV laser can have a very fine spot size, you can get very high resolution down to about 1/10 of a millimeter. You can get build-in thin layers down to 25 microns, although 50 microns is fairly typical, and get very, very good surface finish. And for those reasons, it finds very broad application. The applications include direct models as prototypes. It includes patterns for processes such as vacuum casting, through a process called quick cast. We can make patterns for investment casting, and stereolithography is also being used for direct manufacturing, where the parts we actually build in the process are used as in-use parts. So the application is very broad, and in terms of industry sectors, you really wouldn't find an industry sector today where stereolithography is not being applied. The key ones are, of course, automotive, aerospace, medical are probably the three largest sectors that utilize parts from the stereolithography process. Yeah, there are three machines still being marketed. The first is called the Viper. The second is the SLA 7000, and the third is called the Viper Pro. And the Viper Pro is our latest offering, just introduced in the last 12 months. The primary differences between those systems are the build volume that's available for constructing parts, and also the beam delivery system, that is the laser and scanners that I described earlier, which have gotten better over time and allow you to build higher quality parts. The 7000 is a larger machine. It's also an older generation machine, but it's still very much a workhorse machine within the world of RP. And it has a 500 millimeter X and Y build area, so you can build much larger parts in that system. So the Viper is our smallest system, and it has a work volume of about 250 millimeters cubed. And it has two operating modes, a normal mode and a high resolution mode. The high resolution mode only operates in the center of the XY plane, so you can work in high resolution in approximately half the work area. But in that high resolution work area, you can get, you narrow the beam diameter, and you can resolve features as small as about 1/10 of a millimeter, which for some applications is absolutely essential. Electrical connectors, small medical parts, et cetera, where you have very fine feature detail. The Viper Pro is our latest system, again, introduced just in the last 12 months. And the Viper Pro has a next generation beam delivery system, which we call the ProScan system. And the ProScan beam delivery system has a number of new features. It has digital laser control as well as digital scanner control. It has some feed-forward control algorithms. We have higher resolution encoders. The net result is that in the new Viper Pro system, we can scan at high resolution over the entire work area and build very high resolution parts, very high surface quality over very large work areas.
Hello, my name is Brian Fraser. I'm the Global Vice President of Sales for 3D Systems Corporation. Some hearing aid shells that are produced in a stereolithography on a Viper machine using Dreva resins. Both of these are custom designed to fit the patient's actual ear canals so that it's comfortable either in a clear device or in a colored device. And the inside of the actual hearing aid portion goes inside of the shell, and it fits directly into the ear of the person. So every one of these is custom made for the individual. Another medical application where we use stereolithography to produce biomedical devices. This particular one is for blood testing. So there's a series of grooves and holes. So blood is put into here for doing various tests of blood.